Okay. You guys have this on graph and tracing paper in front of you. I'm going to draw a little sketch, but it's only going to be so-so. So if I have my xy axis, and I plot a point at 3, -4. It's about right there on my graph, right? Yes? No? Yeah. Okay. When you took that tracing paper and you folded it over, because remember, even means y-axis line symmetry. Where did that point move to? What was the new ordered pair? What happened to it when we folded it? Did it move up or down at all when you folded it on the y-axis? No. Did it move left or right? Left. How far left? How many spaces over to the left on the x-axis is it? 3. 1, 2, 3, because it reflected over here. So here's my new point. What's the ordered pair for that one that I have plotted in red? What was the ordered pair when we reflected it? This original point was at 3, -4. -3, -4. So that's what I'm looking for with part A. Part B, I want to leave that blue point in the same spot, so that dot on your graph stays in the same place. But now I want to know where it would move to if this was an odd function. What kind of symmetry does an odd function have? Point symmetry. About what point? Around what? Sort of. X-axis is a line. The middle, the origin. This is point symmetry about the origin. Point symmetry means I'm going to rotate it. How many degrees do we rotate it? How many? 180, halfway around the circle. So if I take this point right here and I rotate it 180 degrees halfway, where does it end up at? -3, +4. It ends up right up here. So -3, +4. You can do this with your tracing paper, where we made that fold. Just hold your pencil down on the origin and rotate it 180 degrees, and you'll watch it turn. Symmetric about the x-axis. Is the x-axis a line or a point? A line. So I'm going to fold it on the x-axis. Where's it going to move to if I fold this on the x-axis? Is it going to move left and right or up and down? Left and right. Remember this one up here where we had y-axis symmetry? I folded it on that line, and so it ended up moving to the left. Up and down. Where's it going to move to? Where's that new point going to be? Up where? Like, what's the ordered pair? +3, +4. What about the very last one? Symmetric about the y-axis. Where's it going to go? So that means we're going to fold it on the y-axis. Didn't we do that already? This is exactly the same as which other one? First one. These are the same. So where's that point going to move to? -3, -4. Awesome. All right. We're going to be in your books today. We're starting on page 23. Guys, I need phones put up. If phones become an issue, they have to come over here in timeout. Right by the door, there's a little container. If your phone is misbehaving, your phone needs to go into timeout. You can see it, make sure that it's no longer misbehaving, and then you can make sure to be the one to go and get it. That's why it's right by the door. Please make sure your phones are put away unless you are using them as a calculator or you need to take a screenshot of what's up on the board. All right. Have you guys ever heard of Bitcoin before? Has anybody ever heard of Bitcoin before? What's Bitcoin? What does it get used for? Yes, sir. It's a type of currency. So you can buy and sell things with it, right? Is it currency like dollars? Why not? Sort of, yeah. It's a digital asset. So it is currency, but it only exists in a digital form. There's no like paper money that goes along with Bitcoins. Does every country use dollars like we do here? What do they use in Europe? Euros. What do they use in Mexico? Pesos. So if I wanted to go to Mexico for vacation, can I take my dollars from here and go spend them in Mexico?
Yeah.
No. Yes, you can. No, you gotta transfer money.
No, I know some places in Mexico you can spend actual dollars there.
Some places you're right, especially large international places.
Yeah.
But like if you're gonna just buy like street tacos.
Oh yeah, you gotta go convert it.
You gotta go convert it, right? You have to get it in the local currency. How do they decide what my dollars are worth in pesos? Is it like $5 is 5 pesos? No. There's an exchange rate. And sometimes it fluctuates, it changes. If you ever watch the news, I tend to avoid this part because I get bored by the economic news that comes on, but they'll talk about how much a dollar is worth compared to other currency. Yes, sir?
Isn't like $1 like maybe 8 pesos or something like that? Or is it like 100 pesos?
So my middle son went there like 3 or 4 years ago. He was part of an exchange program. And it was like 4.5 pesos to the dollar at that point. I don't know what it is anymore because it's something that kind of changes over time. Depending on where you're going, sometimes the exchange rate is almost 1-to-1. Sometimes one of our dollars gets you 2 of their currency. Sometimes one of our dollars only gets you half of their currency. But it's still, the idea is that it should still be able to buy the same amount of stuff. That's how they decide what that exchange rate is. Like if a gallon of milk is $2.50 in the United States, you compare that, you're like, what does it cost in England? Oh, okay, that's how much we're going to make $2.50 worth, kind of thing. Does that make sense? It should have the same buying power in these 2 different places. So I've got a graph up here of the exchange rate as compared to US dollars for Bitcoin. So if you wanted to go buy some Bitcoins, how much is it going to give you? Does anything stand out to you about this graph? Like, what's the lowest that graph ever goes? 200 and something. Right over here all the way on the left. That's the lowest it ever was. What's the highest? 700 and something. Do you think somebody that exchanges this, that's trying to make money doing this, would be interested in the highs and the lows? Do you think that they would only be interested in the one highest or the one lowest? No. Are there any other places on the graph that you think somebody might be interested in? Where?
Where it stayed the same most.
Where it stayed the same-ish, right in here. Anything else stand out to you about the graph? Yes, sir.
Every time it go up.
Every time it goes up, like there's a peak right here, but it's not the highest, right? And then it like has this pretty sharp drop off, but then it picks right back up again. And it has another peak over here. After this peak, what happened? It dropped again. Did it drop back down this far? No. So it's got like these little peaks and valleys, but overall the trend is that it's going up, right? We're going to talk about these two ideas today. We'll have to finish up tomorrow, but we're going to talk about something called extrema. That sounds a lot like what word? Extreme. What does it mean for something to be extreme? Like if someone is extremely rich. Very rich. Like astronomically rich. What would it mean for someone to be extremely poor? Very poor. Like very low amount of money compared to a very high amount of money. Our extrema, that's the plural form of the word extreme. It means I'm looking at more than one. So I'm looking at high points and low points. And we're also going to talk about the behavior of graphs at the end. So I want to talk about extrema first. We are in your book now, page 23. We're up at the top of the page where we're learning about this concept. Maximums. Maximums are the absolute highest point on the graph. When I look at these three graphs, only one of them has a maximum. What do you notice at the top of this graph? Right here. It keeps going. So this one, does this one have a highest point? No. This one, I see a peak. I see this guy right here, but is that the highest the graph ever goes? Why not? Keeps going over here. It gets higher. This graph, does this graph over here have a highest point? Yes. Way up at the top, right here. This is the maximum. Yes, sir.
So if it has infinity, basically there's no maximum?
Correct. If it goes on to infinity up, there is no maximum. You're absolutely correct. Sometimes, and your book doesn't use this, but other websites will sometimes use this, when they talk about the highest point, they'll call it the absolute maximums. You know that there is nothing higher. So far, so good? All right, so maximums are one type of extrema. Minimums are another type of extrema. Do any of these graphs have a minimum, a lowest point, and it never goes below? First one. This first graph has a minimum right here. That is the lowest it ever goes. Again, some places will call this the absolute minimum. Your book just calls it the minimum. So far, so good? All right. If I want to be able to talk about the absolute maximum or the absolute minimum, if I'm asking you a question, does this exist on the graph? And I want to ask it as a single question. I could say, does the graph show any extrema? Does it have a highest? Does it have a lowest? Does that make sense? All right. Does this point right here count as a minimum or an absolute minimum? Why not? Because it still goes down lower than that over here. There are smaller y values. What about this guy? Same problem. He's the lowest in his little neighborhood, but over here and over here we have lower points. It keeps going forever. Those are my absolute maximums and minimums. Your book just calls them maximums and minimums. But there are other peaks and valleys that might be points of interest. Those are called relative extrema. So like a relative maximum That is anywhere I see a peak. You guys see this one right here? How it's a high point? That is a relative maximum. Do you see any other things that are relative maximums? Any other high points? Any other peaks? Yes, sir?
On the third graph, B.
D, yes. These are both relative maximums. This guy over here, we already gave him a name, didn't we? We said he was the absolute maximum. He's also a relative maximum. Just because he's the highest, when I say relative maximum, I mean all the peaks. Is he a peak?
Yeah.
Then he counts. If I want to know about the absolute maximum, he's the only one that counts. But if I just want to know about any relative maximums, any peak counts. What about relative minimums? Do you see any of those up here?
Oh, yeah. It's 3 of them.
3 of them. Where are they? Mm-hmm. We've got one at A. We've got one at C. And we've got one at E. These are relative minimums. Just like I can ask a question to say, does the graph show any extrema? Where I mean, does it have an absolute maximum or an absolute minimum? I can ask a question and say, does the graph show any relative extrema? That would mean all the peaks and all the valleys. I want all of them. Does that make sense? Rather than say, tell me all the relative maxes and tell me all the relative minimums, I just say, tell me all the relative extrema, and I want all of them. So far, so good? Let's look at an example. We're in your book, page 23, about halfway down the page. Before I do that one, though, I want to draw your attention to this. This is not in your book. That graph right there, does it have a maximum? Does it have a minimum? Does it have a relative maximum? Does it have a relative minimum? This one has no extrema at all. That can happen. I might give you a graph and ask you, what are the relative extrema? And you're like, it doesn't have any. And that's a valid answer. All right, I got this guy right here. If I start off on the left side of my graph, I'm imagining that I'm a tiny little video game character here in like just a flat style game. It's not a 3D world. It's like old school Mario. You know how old school Mario, he's just flat and he can move forward and that's it? All right, so I'm over here on the left-hand side of this graph. As I get closer to this yellow dot, am I increasing or decreasing? Decreasing. After this dot, what am I doing? Increasing. Those are my first 2 blanks. The graph is decreasing as it gets closer to 0 on the x-axis. And after that, it is decreasing. Increasing. Ugh. After that, it is increasing as it moves away from x equals 0. This point down here, 0, -5, this is the lowest that the point ever goes. And so is it a maximum or a minimum? Minimum. It is a minimum. So far, so good? On that first graph there. Look at that other shaped graph. Does it have any absolute maximums or absolute minimums? Does it have a highest ever point? What do you see over on the right-hand side? What's happening right here? It keeps going. My picture got cut off, but it keeps going, doesn't it? Does it have a maximum then? No. So, what is this then? Relative maximum. A relative maximum means I'm going to look at that dot and everything in a tight little neighborhood around it. And if it's the biggest thing in its little neighborhood, it is a relative maximum. Does this graph show a lowest point ever? What's on the left side of the graph? Yeah. They didn't draw the arrow, but it ran off my screen, right? So does that mean it has no minimums? Are there any low points, any dips? Head up for me, guys. Stay with me. Head up. This guy's a relative maximum. Is there something that looks like this, but instead of being a high point, it's a low point? Yes, that would be a relative minimum. Where's that at? 4 on the y-axis. This is a relative minimum. All right, so the blanks in your book, I don't really like these sentences down at the bottom, but we'll fill them in. The function is increasing from the left until it gets up to the part of the x-axis where -2 is. Because what's this point right here? What would that ordered pair be? -2 and 8. So I'm moving along here. It's increasing until I get to -2 on the x-axis. And then after that, what's it doing? Now it's going down. Now it's decreasing as we move away from that point. There's no bigger y values right here in this little neighborhood, but there are bigger y values over here. So it is not the highest point on the graph. We say that it is a relative maximum. What's the graph doing right here as I go from left to right? Decreasing. After this point right down here, what's that ordered pair? 0, 4. After 0, 4, what does the graph do? It goes up. So it's decreasing at first, and then it increases. There are no lower y values right there in that same neighborhood. So we can say there's no lesser or no lower y coordinates, no smaller ones. Is this the lowest point anywhere on the graph? No, because over here it continues to go down. So it is not the point lowest, or not the lowest point on the graph. And so that means it is a relative minimum. All right. I'm going to put an example up on my screen that you guys don't have in your books. I actually like this one better than what's in your book. So when we get to the end of it, if you want to snap a picture of it with your phone, I think it's really helpful, especially when we go to do the homework. Head up for me, dear. Thank you. All right. We're going to try to match these. All right. Sit up for me. Does this graph, again, this is not in your books. We're going to do it together up here, and then if you want to snap a picture. Does the graph have any maximums? And I mean absolute here. Does it have a highest point where it never goes higher? I agree with you, no. How do you know? What are you seeing on the graph? It keeps going. This means no maximums, or no maximum, sorry. What about a lowest point? Does it have a minimum? Yes, where's it at? Yes. -6, -7. Here's my minimum. Do we have any relative maximums? Any peaks at all? Yes, I heard 2 peaks. Where are they?
1, 6.
Looks like there's one right here, and it's telling me that the ordered pair there is 2, 6. And -3, 2 would be my other maximum. These are relative maximums. Do we have any relative minimums? How many relative minimums do we have? Be careful. 3. There's one right here. There's one right here. But there's also another one where? The minimum is also a relative minimum. Here's the way I think about relative minimum versus minimum. Do you think if we held a contest at the school, we could figure out who the best singer at Pike High School is?
Yeah.
Yeah. Could they do the same thing over at North Central? What about Lawrence? Yeah. Those would be the relative best singers. In their neighborhood, they're the best. Does that make them the best singer in the state of Indiana?
No.
Could they be the best singer in the state of Indiana?
Yes.
Maybe they are. That would make them the absolute best singer. In their neighborhood, right around there, if they're the best, that would be a relative extrema. But just because you're the best one in the state doesn't mean you're not the best one in the school. You're still the best one in your neighborhood. All right, so we have relative minimums here. I got to get my handwriting under control. Some days it's messy and some days it's not. So those ordered pairs, -6, -7. What's the ordered pair for this one right here? 0, -4. 5, -5. All right. If you want to snap a picture, now is your opportunity. The next problem we're going to look at is on the top of page 24. We're still going to be talking about maximums and minimums, relative maximums, relative minimums. Are you guys okay if we don't fill in the sentences down below? Okay. Your big takeaway here is, can you look at the graph and tell me, does it have any and what are they? So let's kind of keep our focus right there. So what we're going to be looking at is the time of day that people post on very active social media sites and how many posts they make. What would you expect to see? Do you think that like the same number of people post the same number of things all day long?
Mm-mm.
When do you think that you would expect to see a low point? I just didn't hear you. In the beginning, maybe?
A little further away.
During the day. When is like the fewest people posting?
Nighttime.
Like 8 a.m. something.
Yeah, so probably somewhere like, I'm guessing middle of the night. Some people are still posting, but not as many. Where do you think we might see the high points? In the afternoons. Probably somewhere once everybody's kind of up and moving around, maybe after they're out of school. So let's look at this graph. These are the hours after midnight. I was told in fourth period today that your graph looks a little tiny bit different. Mine does not have an arrow at the end, but mine goes all the way to 24. I want you guys to go ahead and scratch out your little arrow on the end. Because this is talking about a day. So I'm going to go from 0 to 24, and that's one whole day, right? And then when I get to 24 hours, I'm back at midnight, correct? So I would start back over here and do the same thing again. So it doesn't really keep going and going and going. Where do you guys see the highest point? Ballpark it for me. Yeah. Right about right here, where x is 12 and y is about what? Y is about 11. If I come over here and look on the table, could I get more precise using the table? What does it have? 11.5. How are they measuring this, though? Are there only 11.5 posts? That doesn't seem like very many. Yeah, it says 100,000. So 11.5 100,000 looks like this. And this is our maximum. If you guys just label the graph in your book, that's going to be fine. We don't necessarily need to fill in all the blanks on the sentences. But I do want you to mark your graphs up so you have something to look at when you're doing your homework. Is there a lowest spot on the graph, a minimum?
Yeah.
Yes. That's about where, if I'm looking at the x-axis. Yeah, it's right about 4. What is the y value there? Yes. Looks like it's at about 1,800,000. So that looks like this. If I write the whole number out, 180,000. Are those the only high points and the only low points? Where's any of the other high points? 16, right about here. X is 16, and Y is about what? 10.2, 100,000. So that looks like that. Is this a maximum or a relative maximum? Relative maximum. Are there any other extrema that I need to notice and talk about? Are there any other extrema or relative extrema? Did I get all the peaks and all the valleys? I see one more thing that's grabbing my attention. Relative minimum. It's in between my two maximums there, right? My two relative maximums. This guy right here. This is a relative min. Falling at about where on the x-axis?
Oh,
14. And what is the y part there? 9.1. 3, 4. There we go. That's what that guy looks like. This is very similar to how I'm going to ask these questions on the homework. I give you a graph. And I want to know, are there any relative extrema What I'm going to ask you to do on the homework, just so there's no confusion, is look from left to right on the graph. Any peaks or valleys you come to. But I want you to start on the left and then move to the right. So if this was a homework question, you'd come to this one and you'd say, that's a minimum. And here's the x part and the y part. And then you get up to this one, you say, oh, that one's a maximum. Here's the x part and the y part. There we have a relative minimum, the x and the y, relative maximum, x and y. All right. So many things. Trampolines. This is a graph of someone who is performing gymnastics on a trampoline. So they're doing flips and jumps and stuff. What do you think is being represented by these pieces? Yeah. What do you think this one would be? Maximum height. That's the highest they ever go in the air when they're doing the tricks, right? What would be happening to the person here? Lowest. Why is it below these other low points? What's happening to the trampoline? It's going down pretty far, right? Like we assume that when they're hitting the trampoline, it's going down a little bit, but she seems to be going down, or he seems to be going down the same amount for each of these. But here, they just came off of this really high jump, and so when they hit the trampoline, it's going to go down pretty far. Let's identify these features. We're going to look at these ordered pairs. We're going to figure out where they go. Is there a maximum here? Is there a highest? Where is it at? 427. 28, yeah. When I look at those ordered pairs, I think you're right. 428, right here. He's my maximum. Do we have a minimum? Where's it at? Six and 1.5, yes. I heard -5 at first. That's why I had to look at the board. All right, so we've used these two. Relative maximums. Yes, just one? How many relative maximums? I want all the peaks. Tell me where you see them. Let's move from left to right. One right here. Anywhere else? 4. This guy is also relative. 7. And where else? One more right here. It's just a little tiny hump. But do you see how it does have a peak? That means it is a maximum. Maybe this is a really small school. Thinking about the singing contest, like it's real small. Let's name those ordered pairs for our relative maximums. We've got 2 what? 212. All right, so we've used this one. We know 428. 721 and 96. So we have 4 of them there. 721 and 96. Relative minimums. Are there any? How many? 4. We've got 1 here. 1 here, this guy, and 1 here. So help me out with the ordered pairs. 0.53, 3, 6, 1.5, yes. And 8, 3. All right, so let's go mark off what we've got. We used this one. We used this one. We have 6, 1.5. We used 8, 3. Any of those ordered pairs fit in none of those categories? One, 6. Doesn't count as a maximum or a minimum. Anything else? 5, 12. All right. Since this is another one that's not in your book, if you want to snap a picture, please feel free. I've got one more question, and then we're done. And by question, I don't mean another graph with a gazillion things. I want to know, in the context of this person performing on the trampoline, what do these maximums and minimums represent? Head up for me, dear. We want to know what the maximums and minimums represent. I'm going to put 4 choices up here. We're going to select everything that we think is true. So far, so good? Okay. Do the extrema represent the height when they begin doing a somersault?
No.
The least and greatest heights of the athlete while performing? Yes. So yes, I'm going to put a check mark here. The parts of the function where the height of the athlete is increasing and decreasing. So how did we name these again? What are these things called? Ordered pairs, right? And when I plot them, what do I get? Just a single dot. Is this the only place where it's increasing? No. Beforehand, this whole space, it's increasing to get up to that, right? And after that point, what's happening? It's going down. But my question is, does this right here represent where it's increasing and decreasing? No. This is when it hits its peak. Before that, it's increasing. After that, it's increasing. But right at that dot, is it going up right then? Is it going down right then? Not yet. Right at that dot. Think about if somebody's jumping on a trampoline and you manage to snap a picture of them right when they're at the top. They're not still going up. They're not still going down, like they're not going down yet. They're right at the peak. It's after they've stopped going up, but before they start coming down. So I would not mark that one. The times when the athlete reaches their least and greatest heights while performing. Would the extrema tell me the times that they're doing that? Yes. The extrema will tell me both of those. It tells me the times and it tells me what the heights are. All right. That's where we're going to stop for today. Tomorrow we'll talk about how to describe the behavior of what's happening on the left and right end of my graph. Homework. I still need to get in and actually extend the deadline, but the homework says it's due tomorrow. I'm going to extend it out a day since we're not finishing the lesson until tomorrow. Okay? There is a homework, though, that is due today. Which one is due today? Yeah. The one that we finished up yesterday, 1-2, that's due today. I did want to tell you guys, I was made aware yesterday that the check button had been disabled because you're supposed to be able in each question to check to see if you got it right before you move on. I did get it fixed, but the way I had to fix it was kind of, The only way I could fix it was to remake the assignment entirely. We had 2 people that had completed and submitted that assignment in this class period. If you are one of those people, it wiped your score out, but I wrote your score down. So if you are happy with your score and you already submitted it, again, this is only 2 people in here. If you already submitted the assignment, but now it's saying you didn't do it, come and talk to me, okay?
Is this the 1-2? Was this check?
This is 1-2. 1-2. So 1-2 is due today. This would be a great way to spend your study time if you haven't tried it already. 1-3 will be due on Friday. All right? Do you guys have any questions for me? Okay.